In this video, we're going to use Django and Plotly to create some charts based on a data set. We're going to start by looking at the data set and we're going to see what columns and features are in the data. After that, what we're going to do is create a Django model based on that data and load it into the database with a management command. And finally, once the data is in the database, we are going to create some charts with Plotly. And these are going to include scatter plots, box plots and line charts. And in the process of creating those charts, we're going to perform some aggregation with the Django ORM, and we're going to see how conditional expressions work when you select or annotate data based on a condition that you specify in the SQL query. So let's start by looking at the data and the GitHub repository. Now we have a GitHub repository here, it's called Django Plotly Demos. There's a starter project there that will help you get started if you're following along with this video. There's a data directory that contains a CSV file of wage data. Now this has been taken from this GitHub repository here, and I'll link this in the description. This is a data set of people's salaries, and it gives you a number of features such as the person's age, the race and so on. At the right hand side, the final column, you can see the person's wages. And in this video, we're going to be looking at the wages, and we're also going to be looking at the person's age to see if there is a trend or any correlation between those two features. We're also going to be looking at the person's education level to see if that is correlated in any way with how much money they make. Now, if you clone that starter project that I've got here, you'll get that data set in the starter code. And the first thing we're going to do is we're going to create Django models based on this data. Now I have this project open in Visual Studio Code, and we have an empty models file at the moment. We're going to add a model that's going to capture this data here. Notably, there are 3 fields that we're going to capture. But before we do that, make sure that you install the requirements that are here in the requirements.txt file. We have Django, Django extensions and Plotly. So let's now go to models.py, and I'm going to open the wage.csv file side by side here with the models file. Now one of the main things we're going to do in this video is we're going to plot the age against the salary. The idea is the older you get, the more money you're likely to make. So we're going to plot that in a chart and we're going to see if it's true. So let's create a model here that we're going to call person salary that will inherit from Django's model class. And we're definitely going to need these 2 fields. First of all, we're going to need the age field, and we're going to make this a positive small integer field. The age is presumably not going to exceed something like 100 in this data set, so we can make that a positive small integer field. Now the person's salary, that's the last column in the data set. You can see that that's a decimal number, and we're going to create a field in our Django model called salary, and that's going to be equal to a float field. We don't need any high precision measurements of this data, so we're just going to make it a float field. You could also use a decimal field though. And there's only one other field that I want to capture in this data set, and that's the education field. So let's copy that into here and we'll make that a car field. So those are the 3 fields that we want to use in our Django model. So let's save that file, and then we can run the python manage.py make migrations command. That generates the migration file for this new model, and then we can run the migrate command to actually create the SQLite database. So that's the model. What we now need to do is we need to actually load that into our database, and we're going to use a management command, a custom command called populate database in order to do that. So let's open that file. This is coming from the GitHub repository. We're going to remove this not implemented error, and now we're going to paste some code into the handle function. Let's start with some imports at the top here. We're going to import the CSV module, and that's going to allow us to actually work with the CSV file of wage data. We're going to load Django's settings, and we're also going to load the new model that we've just created. And within the handle function, we're going to paste some code. Now let me make the terminal smaller and we can go over this code now. First of all, we have a check here to see if we have any person salary objects in the database. If we do, we just delete them all if we run this command. On line 15 here, we set a path to our data file, which is the wage.csv file. And then we use the context manager to open that file on line 18, and we pass the CSV file to the CSV's dictionary reader object. We can then loop over each row in the CSV file, and we can then create a person salary object with that data. And we're appending each one of these to a list called db rows, and at the bottom here what we're doing is using the bulk create command to add these to the database, and we're doing that with a batch size of 1000. And the batch size just means that if we have, let's say, 2500 records in that list, it's going to add 1000 at a time, and then it'll add the final 500 at the end. So if you're following along with this video, just implement this management command, and then what you can do after that is you can run python manage.py, and we just need to specify the name of this custom command, which is populate database. If we run that, we should see that the database is populated. Now to test that out, I'm going to run the shell plus command, and we can then run person_salary.objects.count. When we execute this command, it gives us 3,000 rows in our database. So all of this data has been loaded up. We can verify that by going to the CSV file, and VS Code is showing us 3001 rows in this file. If we subtract the header row, that's 3000 rows, and you can see that corresponds to what we have in the count. So the data is in the database. Let's now start creating a scatter plot with Plotly. So we're here in the views.py file, and what we're going to do is create a new view here. And we're just going to call this function plot for simplicity, and that will take the request as always in a Django view. Now we're going to fetch all of the person salary objects that we've just loaded into the database. So let's import that model from our models.py file. And then within the body of this function, we're going to fetch these objects. So let's say person salaries is the variable, and we're going to set that equal to person salary.objects.all. So we're retrieving all rows from the database. We can then set up a context dictionary, and we can set up a key in that dictionary called salaries that maps to the query set of person salary objects. And finally, what we're going to do is return the render function, and we're going to render this particular template here. It's called scatter.html. So let's now go to scatter.html, and we're going to open that, and you can see we have within the body a simple div tag that contains some text. Let's remove that text, and we're going to simply render out the salaries that we've passed into the context. If we run the Django development server, and we go to the page, you can see we get the default Django template page. So what we need to do is add a URL that's going to map to this new view that we've got. So let's go to urls.py, and at the top we're going to import the views module, and then within the URL patterns list we're going to paste this path here that maps to that new view. If you save that file and head back to the page and refresh, you now see we get this query set rendered on the page. So that's the setup done. We've got the query set that we want to work with, but this is not a particularly nice view for anyone that wants to look at this data. What we want to do is show a visualization of the data. We're going to look at a person's age and their salary, and we're going to plot that on a scatter plot. We're going to use Plotly Express to do this, so let's go to their documentation. And there's a page here for scatter plots in Python. I'll link this below the video. But if we zoom into this code here, you can see there's a function call called px.scatter, and that allows you to build a scatter plot from x and y data. So what we need to do in our views.py file is we need to generate the x and the y data. Now on the x-axis we want to look at a person's age, and on the y-axis we want to look at their salary. So underneath this query set on line 6, we're going to create two variables. Firstly, let's create a variable called ages, and that's going to be equal to the person's salaries that we've got on the line above, and we're going to use the values at list function, and we're going to extract the age field from each model in that query set, and we'll flatten that into a list with the flat equals true keyword argument. And we can do something very similar for the salaries. So we'll create a variable called salaries, and all we need to do is change the field that we're extracting from each model by changing age to salary in this case. So for every row in the database, we get back a list of all the ages and also all the salaries. So that's our x and y data. What we're going to do now is plot that in a scatter plot. So at the top of the views.py module, we're going to import plotly.express as px, and we're getting an import error at the bottom here. So let's stop the server quickly. It says Plotly Express requires pandas to be installed, so let's install that now. Pip install pandas. And pandas is a data analytics library in Python, one of the most popular out there. And once that's installed, you can restart the Django server. Now in order to create the scatter plot, we're going to create a variable here called figure, and we're going to use the px.scatter function. And we can set the x data to the ages variable and the y data to the salaries. And we'll give the plot a title of salaries by age. Once we've done that, we can then render that to HTML. So let's create a variable called HTML, and we'll call the figures2_HTML function. And finally, we're going to change what's in our context here. Instead of salaries, we'll call the key chart, and we'll map that to this HTML that's generated by the Plotly to HTML function. So let's save that and go back to the scatter.html template. What we're going to do here is we're going to render the chart, and we need to use the safe flag in Django, and that will tell Django it can render that HTML that's generated safely, and it doesn't need to escape those characters. So let's save this file and we can go back to our page. If we refresh this page, we should hopefully see that this generates a scatter plot for us. And so it has. We've got a scatter plot here. You can see that on the x-axis we have the ages, And on the y-axis we have the salary, and the salary is divided by 1,000, I believe. Now one thing to note here is that the age is just a discrete number between, let's say, 15 and 100. And the salary, on the other hand, is a float field. So you see these kind of lines that form under the age. A scatter plot is a little bit better when you have two float fields or continuous data on both axes. And arguably it's quite hard to see exactly what's going on here. So let's try and optimize this a little bit. First of all, let's try and change the height so that we can see the dots a little bit better. So we can add a keyword argument called height to the px.scatter function. We're going to set that equal to 800. If we save that and go back to the page and refresh, we should see the height is a little bit bigger here, and that allows us to see more of these dots in the chart. Now it's quite difficult to see a trend in this data. We have a lot of dots kind of clustered together, and then we have some very obvious outliers at the top here. And these outliers indicate that the salary is very high for these individuals. What we're going to do now is we're going to plot a line through this data, the line of best fit, and that's going to minimize the sum of squared differences between each point and that particular line. And it's very easy to do this. It's just a keyword argument to the scatter function. So let's go back to VS Code and we can add that at the end of this scatter function here. And the keyword argument is called trend line, and we set that equal to OLS, which stands for ordinary least squares. Now this isn't going to work out of the box. If we go back and refresh this page, you see that we have no module called stats models. Stats models is a Python statistical modeling package. We can stop the server and we can run pip install stats models here. And once that's installed, just run the Django server, and when that page reloads, you can see the line running through this graph, and you can see the upward trend, and that basically indicates that the older someone gets, the more money we expect them to make. Now this might not be perfectly accurate. You can see that people that are 70 and above typically don't earn as much as people in their 40s, for example. So you might want to look at a polynomial model in real life for this data, but we're just looking at the general trend here. The older someone gets, the more money you can expect them to make. Now there are a lot of dots on this graph, so let's now take this a step further. We're going to filter it down to only the most and least educated people in the dataset. Let's go back to VS Code just now, and I'm going to stop the Django server and we're going to go to the shell plus. And what we're going to do is we're going to fetch the distinct values in the education column. So we're going to say personsalary.objects.values, and we'll specify the education field on the model, and then we can call .distinct on that to get the distinct values back. You can see we have 5 values here. The first one is those who did not graduate high school, and the last one is those who have an advanced degree. So what we're going to do is, instead of fetching all of the objects as we done on line 7, we're going to filter that down based on the education field to only those who have not graduated high school or have an advanced degree. So the extremes in the education column. So I'm going to replace this line here and I'm going to paste in a new line, personsalary.objects.filter, and we're looking at the education column, and we're going to get values of education that match the two we've just mentioned. So if we save that, we can exit the shell and run the server, and we can go back to our scatter plot here and refresh this page. When it loads, we will see a lot less dots because we're filtering out a lot of the data. So what we're going to do now is we're going to use color to show which of these dots belong to the least educated people and which belong to the most educated people with an advanced degree. And it's actually very simple to differentiate these based on color. All we need to do is go back to the view, and very similar to lines 8 and 9 here, we can add another line that fetches the education field from the person salaries that we're getting here on line 7. So even though those don't return colors, what we can do is we can pass them to this px.scatter call, and I'm going to make these on new lines. And we can actually get rid of the trend line here. We don't need that for this example. And we can add another keyword argument called color, and we'll set that equal to what we're doing here on line 10. And that's going to differentiate these dots that are on the scatter plot based on the values of this particular variable. So let's save that and go back to our page, and you can see we now have these dots differentiated based on the education of the particular person. And you can see very clearly in this data that those with an advanced degree, that's the red dots, are much higher in salary than those who have not graduated high school, that's the blue dots. And one of the cool things that Plotly does here on the right hand side, it's got this legend. You can actually click these and you can filter them out of the scatter plot. So for example, if I click this one here, we're removing the blue dots or the least educated people from the graph, and we can bring them back by clicking again, and we can do the same for the red dots as well. But if we look at them together, you can clearly see that those who have an advanced degree typically earn more money than people who did not graduate high school. So that shows you how to do some scatter plots with Plotly and Django and show them on a page. We're now going to show another type of plot called box plots. And box plots show you the distribution of data in a data set. So what we can do is go back to our view here, and I'm going to remove the filter for now, and we'll just fetch all of these person salary objects from the database again. We can also remove the color field here, and we'll remove that from the Plotly call as well. Now, to create a box plot, it's very simple with Plotly Express. Instead of calling the scatter function, we simply call the box function. So let's see if that works out of the box, no pun intended. Let's go back to the page and refresh. And we see now that we have this box plot. For each age in our data set, we're getting the distribution of the salaries for that age. So for example, right at the start of the graph, we have the distribution for 18 and 19-year-olds, and it's very narrow. Those people do not typically earn a lot of money. They're just at the start of their careers. So the distribution is quite narrow there. And in the middle, you can see the box that covers most of the data between the 25th and the 75th percentile. The median is this line in the middle. Now, as people get into their middle ages, you can see that the salary distribution is much wider for those people. And you can also see that there are some significant outliers in this data set that are way beyond the whiskers of the box plot. So the box plot is a useful plot if you have data and you want to get an idea of how it's distributed or how it's distributed between particular buckets. Now, while this may be useful, there are a lot of boxes on this plot. What we can also do is we can aggregate data, and what we're going to do is aggregate it in 5-year intervals. We want to look at the boxes for people, for example, between ages of 20 to 25, and then look at people between 25 to 30 and so on. Now, we're going to use the Django ORM to do this, and we're going to annotate objects based on which of those buckets they fall into. For example, if they fall into 20 to 25-year-olds, we can give it a particular value, and then we can annotate based on that value. So it's easier shown in an example. So let's go back to our views.py file, and I'm going to add some code under this person salaries call on line 7. So we've got a comment here that's showing you what we want to achieve. We want to group all of these by which bucket they fall into for each person. Now, because we're doing 5 yearly aggregations, I'm going to set a variable called years per aggregation, and that's going to be equal to the number 5. If we go back to our data set, you can see quite clearly we have data between the ages of 18 and, at the other side of this plot, 80 years old. So what we're going to do is we're going to set a range expression up here, and what we want to do is we want to start, let's say, from 15, and we want to get ages up to 85 years old. So we'll set the end of the range expression to 85, and we have a skip character here that we're going to set to years per ag, which is 5. So each time this range expression progresses to the next iteration, it's going to skip by 5 each time. So let's set up a variable called age bin, and we're going to set that equal to a list comprehension. So for each number generated by that range expression, so for I in the range, what we're going to generate here is a tuple of 2 numbers. The first number is going to be I itself, so 15 on the first iteration or 20 on the second. And the second number is going to be I plus years per ag minus 1. So each time we're adding 5 minus 1, 4 to that particular number. So that will give us 15 and 19. The second iteration will give us 20 to 24 and so on. So we're generating these boundaries here and we're storing them in a tuple. We're going to use that now to generate some when expressions with Django's ORM. Now, before we do that, let's go to Django's documentation. We're going to go over conditional expressions briefly here. This is the database equivalent of if and else statements. So at the SQL level, you can perform these if and else statements in order to do different things with data that matches different conditions. And in Django, we have these objects called when objects. These are used to encapsulate a condition that you want to apply at the database level. And you can see some examples of this down below here. For example, here we have a when condition that looks at the registered on field of a model and checks if it's greater than a particular date or less than a particular date. What we're going to do in our data, if we go back to the view, we're going to look at each person's salary and we're going to group things depending on which one of these bins they're in. So let's write a new variable called conditionals. And we're going to set that equal to another list comprehension. And at the top here, let's add another import. We're going to import from Django's models module the case and the when objects. So let's go back to the conditionals list here. We're going to create a when object for each value in the age bins. And that when object is going to look at the age field on our model and it's going to use the range lookup. That takes a tuple of 2 values, and that's the lower and upper boundaries that you want values between. So in our case, we can set that equal to a bin for each bin that's in the age bins variable that we have on line 12 above. So for example, if that's set to 20 to 24, what this when expression is going to do is it's going to look at our model, and if that model is between the age of 20 to 24 inclusive, it's going to do something. Now you can determine what actually happens here with the second parameter to the when object, and that is a keyword argument called then. So when that condition matches, we're going to set a value here, and we're just going to make that a string, let's say an F string, set to the bin itself. And we also need to import the value object from Django's models module. So when we encounter a person's salary that matches that condition, where the age is between 20 and 24, it's going to annotate the field with a value of bin. We're going to see how to do that step in a second. So let's remove this line here, and we're now going to create a case object. We'll call that case, and that's going to be equal to that case object we've imported from Django, and we're going to unpack the conditionals that we've just generated in that list comprehension above. In other words, we're going to unpack these when objects in the list that specify a bucket for each of the buckets in our ages between 15 and 85. And for the case, we can specify an output field, and that's going to be equal to a models.car field, and we'll import that from Django's models at the top as well. And we also need to instantiate that object, so make sure you do that. Once we've built up our case condition, we can actually run the query against the person's salary objects. So let's create a variable called age groupings, and that's going to be equal to person salaries, which we got here on line 8. That's just all the rows in the table. We can annotate each of these objects in the query set, and we're going to say age group is the name of the annotation, and we can set that equal to the case. So this case here on line 15 with all the conditional when expressions, we're using that to annotate the age group based on which age range the object falls into. And once we've done the annotation, we can then extract the values of the age group field. And let's print that out to the terminal to see what that looks like. And you can see the different age groupings that we have below here. For example, 15 to 19, 50 to 54, and so on. And these are tuple values because we've set them equal to those tuples using this then part of the when expression. So each object now has an age grouping. What we can now do is go down, and we're going to replace the ages that we had previously on the x-axis, and we're going to paste in this age groups instead. That's going to look at our annotated age group field, and that's going to form our x-axis data. So make sure in the px.box call you put age groups into that field. And if we save that and go back to our page, you can now see that we have these age groupings, and we have much less boxes in the box plot because we're grouping in 5-year intervals of the age instead of displaying every single age. Now one problem here is that the age boundaries at the bottom, they're not in order. You can see it jumps up to 45 here. Now to fix that, we can simply add an order by expression here to the age groupings. When we extract the annotated age group value, we can also order that by the age group. So we use the order by function here, and we can put the age group annotation field. Let's save that and go back to the page, and when we refresh this page, we're going to get back these in the correct order. Now you might be wondering how this works under the hood and what SQL is actually being run by Django. In order to show this, we're going to go back to VS Code, and we're going to use Django extensions shell plus command in order to show the SQL that's being run at a given query. Before we do that, let's go to settings.py, and I'm going to add a setting at the bottom of this file. It's called shell plus print SQL truncate. We're going to set that to 2000. The default is a bit less than that, but we're going to show this query. It's a very long query because of all the case expressions. Once you've set that variable, let's expand the terminal and we can run the shell plus command. And in order to see the SQL that's being run, you can add the print-SQL flag, and that will load the shell but allow you to see the SQL commands. Now I'm going to paste some code into the shell here, and then we can see when we access the salaries what SQL is being run here. Now this is a slightly modified query, but it shows you what a case expression does. We're getting the average salary from the person's salary table, but not over the whole table. We're grouping by the age, and we're binning the age into these different buckets, for example between 15 and 19. SQL has this case expression that's similar to an if statement in a programming language. It allows us to define these groups of data, and in our case we give them tuple values. and then over those groups it's computing the average. So that's the SQL. Let's exit the shell and we'll go back to the page. Let's now plot the average salary like we've done in that query there in a line chart using Plotly. So let's make the terminal a little bit smaller. We'll close the settings file and go back to views.py. The first thing we need to do is change the function call here. It's going to be px.line, and the second thing we're going to do is we're going to calculate the average salary for each of those 5-year buckets of the age field. So in line 17 here, we're annotating the person's salaries with the age group. Let's split this into some new lines so we can see this a little bit clearer. After the order by expression, what we're going to do is we're going to call annotate again. And this time we're going to annotate by the average salary for each of these age groups. Now, because we've called the .values function, our annotation here for the average salary, which we'll call average, is going to be applied to each distinct age group. That's the effect of calling .values before an annotation. So what we're going to do is use the average object from Django, and we're averaging the salary field on the model. And at the top here, we need to import the average object from Django's models. Once we've done that, we can amend what's being passed to the line call here. For each age group, we don't want to pass the salary. What we want to do is pass the average salary. And we do that by referencing the average annotation. That's the name that we've given it here. And that will then reference the average for each age group. Let's now start the server and we'll go back to the page. You can see we get an error here. It cannot resolve the keyword average into a field. And that's because we've actually applied that to the person's salaries that we fetched on line 8 before we did any of the annotation. The annotation occurred on line 17 when we call annotate. We use the case expression to get the age group for each person. And then we further annotate that with the average salary. So we need to reference the age groupings here rather than the person's salaries. If we do that and go back to the page and refresh, we now get this extremely basic line graph that gets the average salary by the 5-yearly age intervals. And you can see that between 15 and 19 the salary is quite low, but it's rapidly rising as people go through their 20s and into the 30s, where it kind of levels off. And then when people reach the age of 60 here, you can see that the average earnings tailor off a little bit. So that's all for this video. We've covered how to build various different plots with Plotly and Django. We've also covered some fairly complex ORM stuff. If it's not clear to you how all that works, try it out yourself and look at the SQL that's being generated under the hood. Django makes it quite easy to build these types of case and when expressions, as you can see on line 13 and 15. This is a little bit complicated because we're doing it within a list comprehension and we're building up these age bins on line 12 as well. I'm soon going to release a series on the Django ORM, which is going to look at these conditional expressions, and it's going to start by building from the basics up. This is a little bit complex, but hopefully you can follow along. So thank you for watching. If you've enjoyed the video, please like and subscribe to the channel, and we'll see you in the next video.